Okay, I'm going to go ahead and let you reassess on this test if you would like to, but in order to do that, you have to go through this test with me and do all of the questions that you got wrong. So I want you to do them on a blank test so that it's clean, and everyone that you miss, I want you to do exactly what I do. So this is the corrections. So if you missed number 1, do number 1 with me. If you missed number 6, scroll forward until I get to 6 and do number 6. So all of them that you missed, you do them with me. Okay, so find the volume. The volume is the area of the base times the height, but the kicker is it has to sit on the shape that it is. So like number 1, this has to sit on the circle. So we have to think of it like that. So we got the area of the base is the circle, and then it's 12 units high. So the height is 12, and we got to find the area of the circle. So it looks like they give us a radius here. So the area of a circle is pi radius squared. So the area of the circle is pi times 10 squared. So the area of the circle is 100 pi. Okay, so that's the area of the circle right there. So the volume is the area of the circle, 100 pi times the height of 12. So it's 100 pi times 12. So we have 100 times pi times 12. Since we're going to round it anyway, that's close enough. So it looks like 3768. Okay, this one is sitting on a 1, 2, 3, 4, 5 kind of shape, and then the height is 11. So I'm going to draw the base down here, what it's sitting on. So it's the area of the base times how tall it is. Okay, so it's telling us right here that the height of that thing is 6.9. That's what that is pointing to the center. And then it looks like it's giving us the edges are 10, so the entire edge is 10, which means half of it would be 5. So that should be enough to find the area of this little triangle. Okay, so the area of a triangle is 1/2 times the base, which is 5 for that one, times the height of 6.9. So 1/2 times 5. So that area is 1725. Okay, that's just this little triangle. So there's another one for the second one. There's a third one, fourth one, fifth one, sixth one, seventh one. Let's see, there were 5 shapes. So there were 5 sides, right? 1, 2, 3, 4, 5, and there were 2 of these little triangles in each one. So there's 10 of these little shapes, these little triangles that I just found. So they're all 17.2. So there's 10 of them. So the area of this whole thing, the area of that base is 172.5. We found this little triangle, and then there was 2 per side, and there were 5 sides, so there should have been 10 of them. So the area of what it's sitting on is 172.5. The volume is the area of the base times the height. So the volume here is that 172.5 times a height. Now the straight up and down height is 11. But then if it comes to a point, it's always 1/3 as much. So then we have to divide it by 3. See, if it would have went straight up and made a straight up prism, we would not have divided it by 3. But if it comes to a point, it's divided by 3. So we need the area of the base, 172.5, times the height of 11, and then cut it all down by 3, 632.5. So the volume here is 632.5. Okay, a lot of people miss number 3 because it's just like number 1, you have to turn it so it's sitting on the shape. This shape is a triangle. We have to turn it to sit on the triangle. This is what it has to sit on. It has to sit on that, which is 6 by 8. Then, so here's what we're sitting on, this triangle right here. So it's got to be turned up. That means this is the height. So it's 11 units tall sitting on this triangle. So the area of a triangle is 1/2 times base times height. So that's 24. So the volume is the area of the base, 24, times the height of 11. Now that does not go to a point. That does not go to a pyramid. So it's 24 times 11. 264. Okay, this one is just like number one. It has to sit on the circle. So it's the area of the circle, then the height is 11. So the circle, radius 4, the area of a circle is pi radius squared. So it's 16 pi. Oops. So the area of the circle is pi r squared, which is 16 pi. So the volume is the area of the circle, area of what it's sitting on. It has to sit on its shape. So it's the area of the base is 16 pi times how tall it is, but then it goes to a point, so we got to divide it by 3. See, if we just leave it 16 pi times 11, it's a cylinder. We want to divide it by 3 so it goes up to a cone. So if it was like this, then we wouldn't divide it by 3. Okay, 16 pi times 11 divided by 3. 16 times pi times 11 divided by 3. 184.2. Volume. Okay, a sphere. A sphere, the volume of a sphere is, let's see, what is it? 4/3 pi r cubed. Let's see, that's the surface area of a sphere. It's 4 pi r cubed. Okay, I'm gonna have to go look that up. No, it's 4/3. It's 4/3 pi r cubed. Okay, so that's really literally all we have to do. It's 4 times pi times the radius is 4.6 cubed, and then divide it by 3. So let's see, 4 times pi times 4.6 cubed divided by 3, 407.5. Probably the hardest part of that was remembering what the volume formula for a sphere was. It's 4/3 pi r to the third. Okay, number 6, we have to make it sit on this trapezoid. So if it's sitting on, so I need to, in my mind, turn it up, and then it will be 10 units high. So 10 is the height. So it's the area of the trapezoid. So the volume is the area of the shape times how tall it is. So the height is 10. So if I were to draw the trapezoid, okay, that piece is 8, the little piece is 5, and then I need the straight up and down height is what they're trying to say there is 3.7. The 4 and whatever that other side is we don't need anyway, because the area of a trapezoid is 1/2 times the two bases, so 8 plus 5 times the height, 3.7. So I need 1/2 times 13 times 3.7. 2405. So the area of the trapezoid is 24.05. So the volume is the area of the base, 24.05 times the height of 10, which is 240.5. Okay, the lateral surface area, and then so we want the lateral and then the surface area. Okay, the lateral is without the tops. Okay, so I need this square right here. Okay, that little thing saying that all of them are 10, so that's 10, and it looks like this right here is right there, so it's 10 by 7. So that one is 70. Okay, then you have another one right here that's 10 by 7. There's another 70. 10 by 7, another 70. 10 by 7, another 70, and 10 by 7, another 70. So, okay, 1, 2, 3, 4, 5 of them. So the lateral, there's 5 of them that are 70. So the lateral surface area is 350. Okay, then you got to add in the lids. So the lids are this shape. Okay, so I'll try to draw that shape again, just so we can see what they are. 1, 2, 3, 4, 5. That's not a very good drawing, but now they're giving us the height of one of these. That's what that 6.9 is right there, 6.9. And then we know one of these is, the whole thing is 10, so that little bit is 5. Okay, now it seems like it just did that one up here. Isn't that this one right here? 6.9 and it was 5. Don't really need to redo it. That area was 172.5. So this area right here is 172.5. That's the top, and then there's another one on the bottom. So the surface area is all of the sides, 350 plus 172.5. And another 172.5. There's the top and there's a bottom for a grand total of 695. Okay, so this one looks like this one has 1, 2, 3, 4, 5 triangles as the sides. So let me just try drawing out one of the triangles. There's one of the triangles. It says, okay, there's the height of that triangle, 12.3. And then all of the bases look like they're all the same. So all of the bases are 8. Okay, well the area of a triangle is 1/2 times the base times the height. So it's 1/2, so it's 4 times 12.3, 49.2. Okay, that's one tall triangle. There's 1, 2, 3, 4, 5 of them. So the lateral surface area is 5 of them at 49.2. So 246. Now for the regular surface area, I got to add in the lid down there. So 1, 2, 3, 4, 5. They're giving me the height right there of 5.5. And then we know the whole thing right here is 8. You know, I could just find this one, since that's the straight up and down height. I'll just find the whole thing, and there will be 5 of those. So 1/2, so the area of just that is 1/2 times base times height, 5.5. So 4 times 5.5. So that little piece is 22. And there's 1, 2, 3, 4, 5 of them. So this whole area is 22 times 5. So this whole area is 110. So the surface area, the total surface area is all the sides, 246, plus the 110 for the bottom is 356. Okay, I need the sides of this one. The sides of this one are just going to be, how about I find the lids first before I do the sides. So I think I'm gonna look at this one that's down here, because they're giving us the straight up and down height of 9.1. So they're giving us this as 9.1. If I can just figure out how long that is. So I need to know how long that is. Well, that looks like it's 12. So there's the lid. The area of that lid is 1/2 times base times height. So 6 times 9.1, 54.6. Okay, so I've got a bottom lid triangle that's 54.6 and a top lid triangle that's 54.6. Okay, now I'm going to go for this. Now I'm going to go for the sides. Well, that looks like a rectangle 8 by 12. So 8 times 12 is 96. So this piece is 96. Here's another 8 by 12. So that piece is 96. Now the bottom I don't think is 8 by 12. The bottom is a square that's 8 by 10. So the bottom is 80. So the lateral surface area is the bottom square and the 2 side squares. So 80, 96, and 96. Add that up on my calculator, is 272. Now I'll add the top lid of 54.6 and the bottom lid of 54.6. Makes the surface area 381.2. Okay, and how about I get so the sides are going to be these squares again, and then the top and bottom will be this trapezoid. So I think it's easier if I get the trapezoid first like I did on that last one, and then I can get the the squares after that. So something like this. So here's the top that looks like that's that 9 right there. The bottom will be 5, and the straight up and down height is 3.5. So the area here is 1/2 times the base 1 plus base 2, so it's 1/2, and 14 times the height of 3.5. So 1/2 times 14 is 7, so I need 7 times 3.5. 24.5. So the top and the bottom are 24.5 each. So now I'll just get the rectangles that build the thing. So here's one of them. It says it's 8, and then that is the same as that. So this is 8 by 4, so that's worth 32. Here I have, there's another little tick mark there, so that's a 4 by 5. So 4 by 5 is 20. No, hold on, that was not a little tick mark down there. This whole thing is 8 units wide. It's 8 there, so it's 8 there, so it's 8 by 5. That piece is 40. So here's an 8, just like it was over there, by 4. So that 8 by 4 is another 32. And here's an 8 times 9. 8 by 9 makes that piece 72. So the lateral is 72, 32, 32, and 40. $176. And now I need to add in the extra. So now the lids, the trapezoid lid is another 24.5 and another 24.5. So 225 total. Okay, so now if we cut this thing in half, so we need to let this thing, so for the lateral surface area, we need to let this thing open itself up a little bit. Okay, so if I were to cut this in half right here and open it up, it gets something like this. Okay, so I call that A to B. So let's say that's the A and that's the B, and I open it up. From A around to B is the circumference. Circumference is diameter pi. So the diameter is 20. So this distance right here is 20 pi. Okay, and then from here to here will be this distance. That's 22.4. So I have this circle. I have this thing opened up. It's 20 pi from there to there, and it's 22.4 there. Okay, that's part of this bigger circle. Okay, so the bigger circle, now this has a remember this was the circumference of that one. So the circumference of this one, the radius is 22.4, so the circumference of this one is going to be 44.8 pi. And the area of this one is going to be pi r squared. So that's 22.4. There's the radius squared times pi. Okay, up here, the area of this one is a fraction part of the whole thing. So to find the area of this piece, which is what we want, okay, look, here's the ratio. Here's the circumference ratio. I know the ratio is 20 pi to 44.8 pi. See, this is 20/44/8 of the whole thing. So if I find the area of the whole thing, so the area of the whole thing is this, the area of this piece is the same fraction as the circumference ratio. So the area of this piece is 22.4 squared pi. That's the area of the whole thing, but see, it's not the whole thing, it's just a small fraction of the whole thing, and the small fraction is 20/44.8. Okay, so what I need on my calculator is 22.4 squared times pi times 20/44.8. So that little partial area, that area up there is 403.36. 703.36. Okay, that's this area down here without the cone. So that's the lateral surface area. That's without the lid. It's 703 point, whatever you want to call that, 4. Okay, then the surface area is just going to add in the circle part, so the area of the circle is pi r squared. So I'm going to add in another 100 pi. So plus 100 pi is 1017.4. Okay, and then number 12, okay, if we cut this thing open, so again, I'm going to cut it right here from A to B. It's going to make the middle part is just going to be a piece of rectangle. It's 11 units tall from that, but now how long it is, that's like the A to B. It's from here unwound to there. So that's just the circumference, which is diameter pi. So since the radius is 10, the diameter is 20. So I know this is 20 pi long. So the area of the middle is 11 times 20 pi. So 11 times 20 pi is 690.8. So this piece is 690.8, which is the middle. And then I need to add the top lid and the bottom lid. So the area of a circle is pi r squared. So it's another 100 pi for the top and another 100 pi for the bottom. So I need to take this 690, add 100 pi plus another 100 pi. 1319.1. Okay, so see number 13, that's this piece right here. So it says sketch the net. So all that is a cone. That's a cone of 8 and it comes up like that. That's what this is a picture of if we cut it apart. It's a cone. Okay, so then the lateral. So the lateral is just this piece and then the surface area is all of it. So I need this. Here's the lateral. So I'm going to do the same thing. I'm going to try to figure out what proportion this is of that. Okay, the circumference of the big one is diameter pi, 19.7 times 2. It's 39.4 pi, so this is 39.4 pi. Okay, this piece right here, when we cut it, is the circumference of this. So it's the circumference of the circle. So the circumference of the circle is 16 pi. So this piece is 16 pi. So the circumference of the big one is 39.4 pi. The circumference of the little one is 16 pi. So our fraction is 16 pi, 39.4 pi. So pi's will cancel out. So there's the fractional part of the area. 16/39. Okay, so if the area of the big one is pi r squared, so it's pi times 19.7 squared. So the area of this will be 16/39 of all of the area. So the area of the part that we want is 19.7 squared pi times the fraction 1639.4. So put all that in my calculator. 19.7 squared pi times 1639.4 is a grand total of 495.1. So the lateral, 495.1. Okay, and then to get the surface area, we just add in the lid. So that was the cone part. That's this, the cone part. Now we need the lid. So the lid is, the area of a lid is pi r squared. So I'm going to add in another 64 pi. 696.2. Okay, this one has got a 5-starred base, like that. And then those are triangles that would all fold up to a point, so they're all going to come up to a point. So to draw that, I'm just going to do it something like that. It's a pyramid with a pentagon base. So the lateral surface area is all of these triangles. Okay, so that triangle should be pretty easy to figure out the area. The area of a triangle is 1/2 times the base. Well, that's 14 times the height, 17.8. So 1/2 times 14 times, so half of 14 is 7. So 7 times 17.8. 124. So this 124.6 is this triangle. There's 1, 2, 3, 4, 5 of them. So the lateral surface area is 124.6. I shouldn't put that in a circle. I don't want that to be part of my answer. 124.6 5 times. 623. And then I have to add in the area of the pentagon, the area of the base. Okay, how about I just do it right here? The base is 14 with a height of 9.6. So the area of the base is, of this triangle is 1/2 times the base of 14 times a height of 9.6. So 7 times 9.6. So that's 76.2. That's this. Okay, there's 1, 2, 3, 4, 1, 2, 3, 4, 5 of those. So the area of the base is 60, this was 67.2, but there was 5 of them. So the area of the base is 336. So the surface area is the lateral plus the base. So 623 plus 336 is 959. Okay, number 5, this is just a square going up to a pyramid. So there's the drawing of that one. Okay, how about I get the area of just this triangle? It's got a base of 10 with a height of 13. So the area of that is 1/2 base times height. So 5 times 13 is 65. So this one is 65, this one is 65, 65, and 65. So the lateral surface area is 65 times 5, 325. Let's see, is that right? No, there's only 4 of them. 65 times 4, 260. Some didn't sound right when I said times 5. There's only 4 sides. Okay, then the box is 10 by 10. The base is 100, so the surface area is another 100 on top of that for 360. Okay, this is a cylinder. If this rolled up, this was a can of soda, a Coke can. The distance from A to B right there is what we need, is 1 time around the circle if we unwind it. It's like up here. If we cut this one, the length of that middle part of the can is from A to B, which is all the way around. So it's the circumference of one of these circles. The circumference of this circle is 10 pi, diameter pi. So this distance is 10 pi. So it's 14 times 10 pi. 14 times 10 pi is 439.8. Okay, that's what the lateral surface area is. Then I got to add in the bottom lid and the top lid. So the area is pi times radius squared. So the radius, if the diameter is 10, the radius, so it's 25 pi. So the area, this one's 25 pi, and the area of this one is 25 pi. So I got to take my 439.8 and add 25 pi and 25 pi. $596.9. Okay, oops, and I forgot to draw this one. This would have been a can. So there's the drawing. A cylinder. This one is just a square. This is just a cube. Okay, it looks like they're all 17 by 17. Okay, 289, so they're all 289. Okay, but the lateral is all four sides without the lids. So the lateral is 289 with left, right, front, and back, so there's four sides, so 289 times 4 is 1156. Then we gotta add in the top and the bottom lid, so add in a 289 twice. So 1734. Okay, this shape is going to be a five-sided, it's going to be a pentagon with all sides, something like that. That one's harder to draw back in there. So there's the shape. So the lateral is all the sides around, so it looks like it's 5 by 9. So these are all 45. So 1, 2, 3, 4, 5 of them. So the lateral is 45, 5 times 225. Now we got to add in the lids. Okay, that's 9 with a height of 6.2. So the area of that is 1/2 base times height. 1/2 times base times height, 27.9. But that's just this piece. There's 2 of them, 3 of them, 4, 5 of them. 1, 2, 3, 4, 5. So if one of them is 27.9 times 5, 139.5 is the whole thing. Okay, so that's the top. So we got our sides, 225. I need to add the top and another one for the bottom. So 225 plus the top, 39.5 plus the bottom, 139.5, 504. Okay, let's take a look at 19. Each pair is similar. Use the information to find the scale factor of the figure. Okay, so here we have volume. So volume is already cubed. Okay, so regular, we have regular, which is 1 to 1. We have area, which is squared, and we have volume, which is cubed. Okay, so the volume here is 3625 to 29000. So I want to take the third root of all of that. Okay. So we need the third root of 3625. All right, so I'm going to take, here's how I like to do it. Third root and 3625 to the 1/3 power are the same thing, so I don't like to go find a third. There's a third root button, which is fine. You could use your third root button of 3625 if you know where to find it. Or we can do it to the 3rd power. Okay, before we get going, I need to see if this reduces. So when I put in 3625 to the 3rd, that didn't come out very clean. So that's giving me the hint that this probably reduces a little bit, and I can see, oh yeah, I should have divided it by 5. So I'm going to take this 3625 over 29000 and hit math fraction, and that'll tell me what it is reduced. Okay, so that's the same thing as 1 to 8. Okay, but that's the volume. Now I need the third root of all of this. I need to third root these. The third root of 1 is 1, and the number that goes into 8 3 times, that's 2. 2 times 2 times 2. So the scale ratio was 1 to 2. Can't really pause this one. I'll come talk to you in a second. Okay, so same thing here. This is volume, so it's already cubed. If we want to get down to the scale factor, we got to uncube it. Well, first, 19683 over 216. It was pi and pi, but those will cancel out. So I want to, on my calculator, I'm going to see what that is. 19683 over 216, math fraction. So yes, that does simplify. So that's the same thing as 729 to 8. But that's volume. I have to third root all of that to get it down there. Okay, I can use my calculator to see what the third root is. So if I go to third root of 8, that'll tell me 2. So the real one is 2, and then 729, oops, I need the third root of 729, that's a 9. So this was a scale factor of 9 to 2. So first we gotta simplify the volume ratio and then cube root it. Okay, this is surface area. Area is only squared. So I'm gonna figure out what the fraction is. Let me simplify 162 fifties. That's 81 25s. So the surface area is 81 to 25, but that's area. I need to now square root that to get it down. The square root of 81 is 9. The square root of 25 is 5. This scale ratio was 9 to 5. And same thing here. This is area. So I have 36 to 16. If I divide this by 4, that's 9 to 4. But that's area is 9 to 4. So if I square root that, that'll get me down to the scale ratio of 3 to 2. So this was a 3 to 2 scale ratio. That means if this side was 3, that side was 2. That makes the area 36 to 16, or 9 to 4. Okay, each pair, similar, find the scale factor of the figures on the left to the right. Then find the ratio of the area and the ratio of the volume. So now we got to find 3 things. Scale factor, which is the first power, area, which is the second power, volume, which is to the third power. So we have regular, we have area, which is squared, and we have volume, which is cubed. Okay, so it already said these are similar, so you can take anything you want to find the scale factor. I think I'll just go diameter to diameter. That's 140 to 98. Let me simplify that so you can see what it is. 140 to 98 as a simplified fraction is 10 to 7. So this thing is going 10 to 7 on the regular scale. Now, it wouldn't have mattered if you used this. We could have done 90 to 63. See, if I divide that by 9, that's 10 to 7. It doesn't matter which one you use. The sides will get you 10 to 7. The diagonals will get you 10 to 7. That's the scale factor. So that means the area are these numbers squared. The area is 100 to 49. So that's the area. The volume are these numbers cubed. 10 to the third is 1,000. 7 times 7 times 7 is 343. So the single scale is 10 to 7. The area is 100 to 49. The volume is 1,000 to 343. Okay, right here, this looks easy, 18 to 6. Well, dividing those by 6, I don't really need a calculator for that. This is 3 to 1. Okay, so that's the regular scale, 3 to 1. The area, squaring these, 9, 1 squared is still 1. Then 3 to the third is 27. 1 to the third is still 1. So there's the scale factor, there's the area, there's the volume. Okay, number 25. These are similar. The surface area and volume are given. Find the surface area and volume of the larger figure. Okay, so this is the small, this is the large. It's 3 to 7. Okay, well that means the surface area scale is 9 to 49, and the volume is 3 times 3 times 3 is 27, and 7 times 7 times 7, 7 to the third is 343. Okay, so those are the ratios. So the surface area, so here I have 9 to 49 is so this is the small one. We're trying to go to large, so the small is 63 going to the large. We'll call it L for large. Okay, cross multiplying that, I have 9L, and 49 times 63 is 3087, so 3087 equals 9L. Divide off the 9 is 343. So the large surface area is 343. Okay, the volume, small to large. Small, 324 to large, so I'll just cross multiply those. This is going to give me 27L. This is going to give me 343 times 324 is 111132 on my calculator. I just multiplied it all out. And then I want to solve for L, so I divide by 27, divide by 27. So divide that by 27, that piece was 4,116. Okay, the scale factor is 1 to 6. So squaring that makes the volume 1 to 36. I mean the area 1 to 36, and 6 to the third is 216. Okay, so this is the small one. The big one's 36 times bigger. We could cross multiply it. It's 1 to 36, and then 17 to x, so it's 36 times 17, 612. So the surface area for this one is 612. And the volume is 216 times bigger. See, I could just crank it up by 216 times. So 17 times 216. The volume is 3672. Okay, almost the same thing for the last ones. Some of the information about, so we're given surface area and volume, find the missing value. Okay, so let's see, here's our surface area. We have 800 to 200. Which simplifies down to, what, 4 to 1? Okay, so the area is 4 to 1. I gotta go to volume. Okay, well I'm gonna square root the area to get it down to regular. So let me go this way. I'll square root the area, get it down. So the square root of 4 is 2, the square root of 1 is 1. So the scale factor is 2 to 1. Okay. So to get up to the area, we squared it, was 4 to 1, which was what that was. Okay, to get to the volume, which is what we need to cube it. That means 2 times 2 times 2. And 1 times 1 times 1. So here's the scale factor for volume, 8 to 1. Okay, so this is big to small. We're going large to small. So this is going large to small. So I have 8 to 1 is 17,000 to small. So cross multiplying, I have 8x equals 17,000. So I just need to divide 17,000 by 8. Is 2125. So see, they gave us the area. We had to crank it down to the surface area and then crank it back up to the volume. So they're doing that again here. They're giving us the area. I got to crank it down to regular. So let's see what it is in the first place. It's 576 to 1296, but that probably can be simplified. 576 divided by 1296 is 4 to 11. So that's really the fraction 4 to 9. But that's area. So if I square root the area, I'll have regular. So square rooting 4 is 2, square rooting 9 is 3. So the scale factor is 2 to 3. Going small to big, small to big. Okay, squaring that, so the area is 4 to 9. The volume, we got to go 2 times 2 times 2. 8, 3 times 3 times 3 to 27. So the volume ratio, if the area ratio was 4 to 9, the regular ratio was 2 to 3, the volume ratio is 8 to 27. So I have 8 to 27. Now let's see, I want to go, this is small to big, so small to big, so small is 1080 to unknown. So when I cross multiply, that gives us 8x, 27 times 1080 is 29,160, and divide off the 8. 3645. Okay, 29, they're giving us the volume. We gotta get it down to surface area. Okay, let me see what it is. 540 to 6860, that can be simplified. I certainly can cut off the zeros. I'll let my calculator do it. 540 divided by 6860, math fraction. It's really 27 to 343. Okay, but that's volume now. Okay, I got a third root volume to get it down to regular, so I need the third root of 27. The third root of 27, 3 numbers that make 27. That's 3 times 3 times 3. So the third root of 27 is 3. This is 7 times 7 times 7. So the scale factor is 3 to 7. The regular scale factor, going from small to big, is 3 to 7. So when I square that up, that's where 9 to 49 comes from. That will be the surface area. And if I go take it to the cubed, that's 27 to 343, which is what we saw in the first place. But this is the one I need, 9 to 49. So small to big is small to big. So here I have 9x. Here I have 54 times 49 is 2646. So 2646 divided by 9 is 294. And the last one is just like that. So now it looks like we're going big to small. So I got 14,000 over 4802. So 14,000 over 4802 as a simplified fraction is 1,000 to 343. That's volume. Oops, that's volume. So I need the third root volume. So I'm going to third root all of that. Well, 3 numbers that make 1,000 is 10 times 10 times 10. And 3 numbers that make this for the second or third time now we already know is 7. So the scale factor going from, this is the big one and it's going down. So this is the big one, it's going down. So our scale factor is 10 to 7. To get that to area, I got to square it. So it's 100 to 49. So for area, I have 100 to 49. That's big to small. Is 200 to blank. Now, so this one should be smaller than 200. This one was smaller than 14,000. This should be smaller. So here I have 100x. 200 times 49 is 9,800. Divide by 100. That's 98. So it did get smaller. Okay, so you can, if you need to watch some of those again, just slow it down. And I tried to go fast so we could get through it in a reasonable amount of time. Okay, so if you want to reassess, you got to have all the ones you had wrong with all of the work that I have, and then you can reassess.